Dear students, in this video I am discussing the organic chemistry questions from KEAM 2020 question paper. KEAM 2020. The question is to find out which compound is a benzenoid. Benzenoid is nothing but benzene containing aromatic compounds. We can check each compound. First one is cyclooctatetraene. Cyclooctatetraene. This is cyclooctane tetraene, that is double bond in 4 sides. So first double bond is here, next double bond is here, next double bond is here, next double bond is here. It is very clear from this picture that it does not contain benzene ring. So this is not a benzenoid. Now we can check the next compound, hexane. It does not contain a benzene ring. Next is cyclohexane. It's very simple cyclic compound. Listen here. It does not contain benzene ring. Next one is toluene. What is the formula of toluene? There is one CH3 group on benzene. So this is the correct answer. Next compound, cyclopentadiene. What is cyclopentane? This is cyclopentane and this is cyclopentadiene. Here the answer is option D, that is toluene. Next question is to find out the ozonolysis product of 2-methyl-but-1-ene. So firstly, we can write the formula of 2-methyl-but-1-ene. The longest carbon chain contains 4 carbon atoms. Here the root word is but. C, 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 C. One methyl group is present on second carbon. One double bond is present on first carbon. So we can write, give hydrogen here CH2. Here there is no hydrogen. Here CH2, here CH3 and here CH3. How can we find out ozonolysis product? It is very simple. We can cut this double bond and we can add one oxygen here and one oxygen here. This product is nothing but HCHO, that is formaldehyde, and this compound is nothing but butanone. What's the formula? CH3, the CH3, single bond C, double bond O, single bond CH2, single bond CH3, butanone. This compound is methanol or formaldehyde. It is very clear from the given options. The correct answer is C, that is butanone and methanol. Methanol is the UPSC name of formaldehyde. In this question, we have to find out a compound which is not an isomer of 3-methyl-but-1-ene. So firstly, we can draw the formula of 3-methyl-but-1-ene. 2, 3, 4, 3-methyl, triple bond is present here. And we can count the number of carbon atoms, 1, 2, 3, 4, 5. So C5. Next hydrogen, here 3 hydrogen atoms, here 3 hydrogen atoms, here no hydrogen but here 1 hydrogen. And here 1 hydrogen is present. total 8 hydrogen atoms. So C5H8 is the formula of this compound. Isomers have same molecular formula but different structural formulae. We can examine the formula of this compound 2,3-dimethyl buta-1,3-diene. Here the root word is butyl. So 2,3,4-2,3-dimethyl, that is here one methyl group, here also one methyl group. Then 1,3-diene. There is a double bond on first carbon and there is a double bond on third carbon. 1, 2, 3, 4, 5, 6. C6 and hydrogen. Here 2 hydrogen atoms. Here 3 hydrogen atoms. Here no hydrogen. Here no hydrogen. Here 3 hydrogen atoms. Here 2 hydrogen atoms. That is C6. H10 is the formula. It is very clear that the correct answer is option A. Why? Option A has the formula C6H10 and the given compound has the formula C5H8. So these two compounds are not isomers. We can find the formula of pent1-ine 2, 3, 4, 5. Pent1-ine 2, 3, 4, 5. Pent2-ine. Both has same molecular formula C5H8. You can find it very easily. Penta-1,3-diene 2, 3, 4, 5. Penta-1,3-diene. Okay. Here 3 hydrogen atoms. Here 1 hydrogen atom. Here 1 hydrogen atom. Here 1 hydrogen atom. Here 2 hydrogen atoms. So 2 plus 1 3, 3 plus 1 4, 4 plus 1 5, 5 plus 3 8. That is C5H8, isomer of the given compound. Now we can examine this compound 2-methyl buta-1,3-diene. That is 4 carbon atoms in longest carbon chain. 1,3-diene. Here in these two positions there are double bonds. Methyl group is also present. Now listen here. Here 2 hydrogen atoms. Here 3 hydrogen atoms. Here 1 hydrogen atom and here 2 hydrogen atoms. So 2 plus 1 3, 3 plus 3 6, 6 plus 2 8. This compound has the formula C5H8. Here the correct answer is option A. Here the question is to find compound which does not undergo SN1 mechanism. SN1 reaction takes place in 2 steps. In first step, there will be the formation of carbocation. So, as the stability of carbocation increases, then the possibility for SN1 reaction increases. In first case, by leaving of Cl minus, there will be the formation of C6H5CH2 plus, that is benzyl carbocation. Benzyl carbocation. Now the cation formed from this compound is C6H5, that is benzene ring, then CH, then CH3, this CH3. Chloride ion will be left from this carbon, so this carbon gets a positive charge. Next, third compound, by the leaving of this Cl minus, then this carbocation, phenyl carbocation is formed. From the fourth compound, the carbocation formed is nothing but CH3CH2 plus. In fifth compound, the carbocation is formed C6H5, that is benzene ring, then one CH, then once again a benzene ring and this a plus charge. we will discuss a detailed video about the stability of carbocations. Among these carbocations, which one is most stable? This carbocation is most stable. That is, it undergoes SN1 reaction fastly. Okay? Why? This positive charge is in conjugation with two benzene rings. That is, resonance will be maximum in this case. Which carbocation is least stable here? It is very important carbocation, that is very less stable carbocation is nothing but phenyl carbocation. That is, in benzene ring, there is electron deficiency in one carbon that will affect its resonance badly. So it will never leave Cl minus ion. That is, chlorobenzene will never undergo SN1 reaction. Okay? Least stable or very less stable. That is why C6H5Cl will not undergo SN1 mechanism. If we are arranging these carbocations in the decreasing order of stability, then we can write E is more stable. The carbocation formed from E is more stable than B, this compound B, which is more stable than A, which is more stable than D, which is more stable than C. Here maximum resonance, here one resonance part and next hyperconjugation part. Here resonance and here only hyperconjugation. Here no resonance and no hyperconjugation. Okay. So this carbocation is very less stable. This is the order of stability of carbocations. Okay. The question is, which one is a secondary alcohol? Listen here, first compound is 2-methyl-butan-2-ol. Here OH group is attached on a tertiary carbon. So this alcohol is an example for tertiary alcohol. The second option is 3-methyl-butan-1-ol. This is first carbon, second carbon, third carbon, fourth carbon. 3-methyl-butan-1-ol. Here OH is attached on a primary carbon. So this is an example for primary alcohol. Next option is 2-methyl-butan-1-ol. Here also OH is attached on a primary carbon. So this is an example for primary alcohol. Now in option D, 3-methyl-butan-2-ol. Here OH is attached on a secondary carbon. So this is an example for secondary alcohol. The answer for the question is option D. In KEAM entrance examination, 5 options will be there. Okay. In NEET examination, only 4 options will be given. That is the difference between NEET and KEAM in question pattern. Now listen here, this compound 2,2-dimethyl-butan-1-ol. Here also OH is attached on a primary carbon. That is why this is also an example for primary alcohol. Okay. In this question, the given informations are a compound A which has the molecular formula C7H6O. C7H6O, the compound will be an aromatic compound, benzenoid. If the number of carbon and hydrogen are nearly the same and more than 6, then definitely the compound will contain benzene, most probably, especially for you. So this compound is a benzenoid. when the compound is treated with 2,4-dinitrophenylhydrazine, the derivative is formed, and also it gave positive tolerance test. That is, it reduced tolerance reagent, ammoniacal silver nitrate. So from these two informations, it is very clear that the compound is aldehyde. Which is the benzene containing aldehyde? Benzaldehyde. We can check the formula, that is CHO. Listen here, number of carbon atoms 1, 2, 3, 4, 5, 6, 7. C7, hydrogen, here 1 hydrogen, 2 hydrogen, 3rd, 4th, 5th and 6th. 6 hydrogen atoms. Here there is no hydrogen atom and 1 oxygen. So the formula is set for this compound. Then for the confirmation, next step is given in the question. That is, when the compound is treated with concentrated NaOH, in question paper that is given as KOH, that is by mistake, concentrated NaOH, then sodium benzoate and B is formed. What is B? That is the question. You know that this reaction, that is the reaction of an aldehyde which does not contain an alpha hydrogen, when treated with the concentrated sodium hydroxide, disproportionation reaction takes place. That is, Cannizzaro reaction takes place. So this is Cannizzaro reaction. In Cannizzaro reaction, one compound is acid derivative by oxidation, and the second compound will be an alcohol. Which alcohol is formed from benzaldehyde? Benzyl alcohol is formed from benzaldehyde. So the reduction of benzaldehyde gives benzyl alcohol. Oxidation of benzaldehyde with concentrated NaOH gives sodium benzoate. This is Cannizzaro reaction. Next question is, which of the following undergo Cannizzaro reaction? You get this question? And in previous question also, the question was from Cannizzaro reaction part. Okay. So two questions are asked from Cannizzaro reaction only. The first compound is 2-methylpentanal. Listen here. Cannizzaro reaction is only for the compounds having no alpha hydrogen. This is alpha carbon, there is 1 hydrogen atom is present. So this compound does not undergo Cannizzaro reaction. Here also alpha hydrogen, 2 alpha hydrogen in this side, and in this side also 2 alpha hydrogen. So this does not undergo Cannizzaro reaction, and also this is a ketone. Now third compound, 2,2-dimethyl. This is alpha carbon. Here no alpha hydrogen is present. So this is the answer for the question. Why? There is no alpha hydrogen in this compound. 2,2-dimethyl butanol. Now option D. This is alpha carbon. This is also alpha carbon. There is alpha hydrogen. Not only but also this is a ketone. And the last option, phenyl acetaldehyde. This is acetaldehyde. One phenyl group is attached to acetaldehyde. This is alpha carbon. It contains alpha hydrogen. So it will never undergo Cannizzaro reaction. So option C is the correct answer. Next question. Which of the following compounds is prepared by Gabriel Thalimide synthesis? In +2 amines chapter, you have learned in detail about Gabriel Thalimide synthesis, and Gabriel Thalimide synthesis is only for aliphatic primary amines. Now listen here. Option A is aromatic amine, 2 aminotoluene. Then second compound, pure aniline, which is aromatic amine, and this is also aromatic amine. So Gabriel Thalimide synthesis is not to be used for these compounds. Now look at next two options. Here is NH2 group, that is, this is a primary amine, and also this is aliphatic amine. Aliphatic primary amines can be prepared from Gabriel Thalimide synthesis. This is also aliphatic, but this is secondary. Secondary cannot be prepared by Gabriel Thalimide synthesis. So B is the correct answer. This is allyl amine. This is allyl group. Okay. Here I am explaining what is Gabriel Thalimide synthesis. This is Thalimide. Thalimide is a derivative of thalic acid. So Thalimide. CONH2, then that is thalamide. This is one amino group connecting to both the keto groups. Okay, that is why this is thalimide. When thalimide is treated with KOH, HOH minus H2, water will be removed to form this salt. Okay, in second step, that is treated with alkyl halide. In that position, as we know from the question, allyl chloride or allyl bromide will be the reagent here. Listen here, CH2 double bond CH, single bond CH2, then Cl or Br, whichever it may be, no problem. Then what happens? This is the alkyl part here, like this one. Okay, R will be attached here, K and Br minus KBr. KBr will be eliminated and R will be connected to this compound. In that position, this allyl part will be attached. Allyl part will be attached fastly because Cl minus will be going from here fastly, because as a result of leaving of Cl minus, allyl carbocation will be formed. This is a stable carbocation. That carbocation will be attached to this nitrogen. In next step, hydrolysis takes place and this bond is broken. 2 H hydrogen atoms come this side for the formation of RNH2. RNH2. Then this is phthalic acid. Phthalic acid. Phthalic acid is the byproduct in Gabriel Thalimide synthesis. If an aromatic amine is formed from Gabriel Thalimide synthesis, then we should use aryl halide. But aryl halides are very less reactive in nucleophilic substitution reactions. Why? If halogen is attached to an aromatic ring or benzene, then Cl minus will never come out, because since after the leaving of Cl minus, there will be the formation of very less stable phenyl carbocation. So this will never take part in this reaction. That is why Gabriel Thalimide synthesis is used only for aliphatic primary amines, not for aromatic and not for secondary or tertiary amines. The last question from pure organic chemistry chapters, that is also from amines. That is, the reagent used to distinguish between secondary and tertiary amines. Okay? Diluted Cl and diluted NaOH both are not used for identification of primary, secondary and tertiary amines. Now listen here. This reagent is used to identify aniline bromine water test. Aniline 2,4,6-tribromoaniline white precipitate is formed. Now listen here. Secondary and tertiary amines can be distinguished by Hinsberg test. So first compound is Hinsberg reagent. We have studied Hinsberg reagent as benzene sulfonyl chloride. Benzene sulfonyl chloride. Okay? But here para-toluene sulfonyl chloride is given. Both are same family. Okay? So this can be used as Hinsberg reagent. A is the correct answer. That is used to distinguish between primary, secondary and tertiary amines. Now option D, CHCl3 in presence of alcoholic KOH, that will lead to the formation of RNC, that is isocyanide carbylamine. This test is known as carbylamine test. That is only for carbylamine test is only for primary amines. That is used to distinguish between primary amines from other amines. But here the question is distinction between secondary amine and tertiary amine. For that purpose, this reagent only is used.